So we are looking at a glancing collision. So at the heart of every two-dimensional collision problem, essentially, is the conservation of momentum. In grade 12, we don't have to worry about kinetic energy. What we're looking at is a fully elastic collision between ball 1, or puck 1, more appropriately, which has a mass of 1/2 a kilogram and an initial velocity of 1 meter per second and 0 degrees relative to the positive x-axis. And so we're doing our directions based on the Cartesian plane. It's going to strike slightly off center a second ball with a mass of 1.5 kilograms that's stationary with a velocity of no meters per second. The final velocity of the first ball is 0.58 meters a second, and it's directed 124 degrees relative to the positive x-axis. Our job is to figure out the velocity of the second ball. Now, you're not obliged to use a table. If you look at a lot of the way these problems are solved, keeping track of initial, final velocities, masses, momentums are done sometimes with subscripts and sometimes with little primed signs to indicate that this is the momentum after the collision. It all adds a lot of symbolic processing to trying to figure out what the answers are. You can, on the other hand, go with this initial and final table to try and find out what all the momentums are, because this is the heart of the problem. We're going to have conservation of momentum, and conservation of momentum works with orthogonal or perpendicular components. They are essentially independent, and they have to add up to the same thing before and after the collision. And so we've done a little bit of calculating here. What we've done is we've put in our momentum for the first ball in the x direction. It's 0.5 kilograms meters per second. The second ball is, there is no momentum in the y direction because it's running along the x-axis, in the x orientation. The second ball is stationary, and so both of its momenta in the x and y position are 0. So we can figure out our total momentum is 0.5 kilograms meters per second in the x direction, and it's 0 in the y direction. Because momentum before is preserved, we can figure out that the total final momentum in the x direction also has to be 0.5 meters per second, kilograms meters per second square, and whatever it adds up to in the y direction, it has to add up to 0. And so even though we have our balls running off in different directions, and you can see there is a y component to the velocity, when we add the momentums together in the y direction, they're going to have to add up to 0. Okay, so let's do a little bit of SOHCAHTOA here. Basically, we need to take this ball's momentum, and we need to figure out what the x and y components are. And we can just do that using SOHCAHTOA. So the fact that it's got a velocity of 0.58 meters per second, it weighs 1/2 a kilogram, and it's oriented 124 degrees relative to the x-axis. We can figure out the x component and the y component of momentum that way. Okay, and much like the Galloping Gourmet, I happen to know what those are. And so the final momentum of mass 1 in the x direction is negative 0.16. And so you can see that it's actually headed backwards. And in the y direction is 0.24. Okay. Now we can figure out exactly what the momentum in the y direction is and the x direction for the second mass. And so something plus negative 0.16 has to add up to 0.5. And so this has to be 0.66 kilograms meters per second. In the y direction, everything has to add up to 0, and so this has to be negative 2.24 kilograms meters per second in the y direction to add up to 0. If we're asked to find velocity for the second ball, we can just simply go through momentum. The second momentum is equal to the mass of the second ball times the velocity of the second ball. And, the one thing we didn't do was actually work out what our angle was. But we can use SOHCAHTOA to do that. Going to do that right now. And so I've got my x and y. Arctan is going to be the easiest thing, so I'm going to do the arctan of negative 0.24 divided by 0.66, and I get negative 19 degrees. So my direction is negative 19 degrees. And my total momentum for the second one, I'm going to have to use the Pythagorean theorem here. So 0.66 squared. And so the total momentum here is 0.70 kilograms meters per second. And I can find my final velocity. Oh, and sorry, this is oriented on an angle of 19? 19 degrees. Okay. And so there's my final velocity for the second mass. It's going 0.46 meters per second at an angle of negative 19 relative to the x-axis.